Hi, welcome back to part 2 of Basic Operations with Real Numbers for Mthpt-103. So in part 1 we were discussing, addition of integers and subtraction of integers. Now we are moving on to multiplication, and then we'll be doing some division. The rules with multiplication and division of integers is if the signs are the same, then it is a positive. If the signs are opposite, then it is a negative. So on number 11 here with -9 and -10, since I have the same, a negative and a negative, I have a positive answer. And so then in my head or on a calculator, I can do 9 times 10. 9 times 10 is 90. Versus the next one where the signs are opposites, I have a negative times a positive. My answer has to be a negative. 9 times 10 is still 90. But you can see the answers are different because I had 2 of the same sign versus on 12 I have 1 of each sign. Now the sign rule applies even when I move down to division. If the signs are the same, there it's a positive. If the signs are opposites, it's a negative. So -38 divided by -2, my signs are both negative, so my answer is a positive. 38 divided by 2 is 19. I have a positive and a negative. My signs are opposites, so my answer is negative. 92 divided by 4, if I take a moment and do that, it's 23. Now this can be applied in situations as well. For instance, number 15. 6 pieces of wood were glued together. If each piece had a thickness of 1.625 inches, what was the total thickness of the final piece of wood? So I have multiple things that have the same length. So instead of adding the 1.625 6 times, I can do 6 times 1.625. Since I have a positive and a positive, they're the same. My answer is a positive number. You don't have to write the positive symbol. Then I'm going to grab my handy calculator. 6 times 1.625 gives me an answer of 9.75. Whenever you're doing situations, you should always label your answer if possible. This problem is working in inches, so I want to make sure I label it in inches. Number 16, if 54 cupcakes were to be shared amongst 6 groups, how many cupcakes does each group receive? I have to break those cupcakes apart so each group gets some. Since I'm breaking them apart, I am dividing. So 54 divided amongst the 6 groups. 54 divided by 6 is 9, but again, I want to label my answer, so it is 9 cupcakes. I had a positive and a positive, so my answer was still a positive. But again, you do not have to write the positive plus sign. Okay, so we're done with integers. We've done adding, subtracting, multiplying, and now dividing. So in the real number system, we also have fractions. So we're going to move on to fractions. This will take a little bit longer because there's a few more rules with fractions. So the first problem is 3/4 plus -6/7. Now the rules that we applied in integers is still true as far as if the signs are different, you have to see who you owe more to. You can kind of think of this as instead of owing whole amounts of dollars, you're now owing partial dollars. You cannot put fractions together if the bottom numbers are different. So one's 4, the other fraction has a 7, so we must have a common bottom in order for them to go together. The easiest way to get a common bottom is to take the 7 that's on the second one and multiply it by the top and the bottom on the first fraction. And then take the 4 on the first fraction, multiply it by the top and the bottom on the second fraction. Now the multiplying is to get the common number, and if I do it to the bottom, I have to do it to the top. The reason I just did this, the 7, over to the other side is I don't have to think about what do both 4 and 7 go into. There may be a smaller number, there might not be, but this way I can just keep moving. So 3 times 7 is 21. 4 times 7 is 28. The negative doesn't change. Signs are staying the same at this point. 6 times 4 is 24. 7 times 4 is 28. So both of my bottoms are now 28. So I can actually do the fraction and add them together. Now the nice thing is I can think back to my integers. The 28 is just the size. So it doesn't change. It stays 28. Now I can think of my integers. I have 21. I owe somebody 24. I definitely owe more than I have, so my answer is going to be a negative. So then I can come over to the side. What's the difference between 24 and 21? It's 3. Since I owe more than I have, I owe 3 28ths. So that's some partial of $1 or partial of a cupcake or whatever I want to owe partial of. So this is my final answer. Now if I look at 18, I've noticed that the negative is on the bottom. That is confusing to me. So it is perfectly legal to take that negative and just move it up on the top. That keeps my signs all together. If it's a negative, it stays on top. If it's a positive, it would be on top. Now again, I have different denominators. One's a 9, one's a 7. So I'm going to multiply the 7 times the other fraction, both on top and bottom. And I'm going to take the 9, multiply the other fraction, both top and bottom, by 9. So my first fraction, still negative. 8 times 7 is 56. 9 times 7, 63. Still adding. Still have a negative on the second fraction. 6 times 9 is 54. 7 times 9 is 63. 63 is like the name of the fraction, so it doesn't change. It's still 63. The top is where I'm doing the math. I owe 56. I owe 54. So I owe even more than I did before. Still a negative because I'm owing. Since my debt is becoming larger, I have to put the two numbers and add them. So 56 and 54 is 110. So it's negative 110 over 63. Now, in fractions, you should always try and make them smaller if at all possible. So 110 and 63, you want to ask yourself if they're divisible by anything, and they're not. Nothing goes into both 110 and 63 except for the number 1. So we're just going to go ahead and leave our answer as an improper fraction. As you look at 19, you might notice that the first fraction is like what we've been working with in the first two, but the third one is actually what's called a mixed number. It has a whole part, which is the 2, and it has a fractional part, which is the 7/18. To do the math that we've been doing in the first two problems, we cannot work with this as is. Instead, what we're going to do is change this to an improper fraction, which is like the answer we had previously. So I'm going to leave the 4/9 as is to start. The second fraction is a negative, so I'm going to make sure it stays negative. Now I'm going to ignore the negative. It's not there. I'm just going to work with the numbers. So I'm doing 18 times 2 because I'm ignoring the negative. 18 times 2 is 36. I'm ignoring the negative, so I just do 36 plus 7. 36 plus 7 is 43. Bottom doesn't change, it's still 18. So I've changed the negative 2 and 7/8 to negative 43/18. It's now improper, and I can do the math that I need to do. Now this one I can do the same thing I've been doing previously. I can multiply the 18 times both of them, and I can multiply the 9 by both of them. I want to show you a different method on this one because I'm going to end up with a huge number if I don't. This 9, I notice right away, actually goes into 18. You might notice that too if on your, sorry, I'm changing colors. On the idea here of, you know, your multiplication tables, 9 times 2 is 18. Now I can change this to 18, but if I do it to the bottom, I have to multiply the top by 2 as well. 4 times 2 is now 8. 9 times 2 is 18. My bottoms are going to match now. I'm just going to bring over the negative 43. Since the bottoms match, I'm going to put them together. Bottom doesn't change, it's like the name of the fraction. I have 8, but I owe 43. 43 is definitely more, so my answer is negative because I owe more. I'm going to come over here. I owe 43, but I gave them 8, so now I'm down to owing 34. So since I owe, it's a negative 34 over 18, which is like the name of the fraction. Ooh, I almost marked it as being done, but you may have just noticed what I noticed. I'm not sure why it just scrolled down. Let me get rid of that line. I'm going to delete that. Okay, so what we're going to do now, still colors, okay, so both of these numbers are divisible. They're both even. So since they're both divisible by 2, let's divide by 2. That'll make it smaller. So half of 34 is 17. Half of 18 is 9. So now I want to look at 17 and 9. Does anything go into both of those? Not anything except for 1. So now I'm done with my answer. Got a little excited earlier. Number 20 does similar math except it's a minus. So we're going to change this minus to a plus, and we're going to still do the same idea of getting a common bottom. I'm going to go back to the blue. Okay, so let's go ahead and change this to a plus first. So the first fraction, I guess my pen doesn't want to go blue. Okay, we'll just leave it. Negative 7/8. We're going to change the subtraction to an addition, which is legal as long as I take the second and I also change it. So my negative 9/4 is going to go to a positive 9/4. Now I'm halfway there. I need to get these bottoms to be the same. I notice that if I double the 4 or I multiply it by 2, it will become the 8. So let's multiply the 4 by 8. So timesing by 2, so I become 8, times the top by 2, so I become 8. First fraction stays. 9 times 2, 18. 4 times 2 is 8. Can go ahead and put my bottom down because that's my name. And I can look at the tops. I owe 7, but I have 18. Well, since I owe 7 and I have more than I owe, my answer is going to be a positive because I'm going to still have money left over. 18 that I have in my pocket, take away the 7 that I owe them. I now have $11 left. So I have a positive 11/8. Does anything go into both 11 and 8? Only 1. So I'm good to go on my answer. Okay, our situation, let's look at it. A ski resort received 17.5 inches of snow in December, 15 7/8 inches in January, 29 3/4 inches in February, and 15 3/8 inches in March. How much snow did the resort get during these 4 months? Since I want to know what they got all together, I am adding my numbers. Now, one thing I'm noticing on this one, our denominators are 8, 2, 8, and 4. And I'm adding. When you have mixed numbers and you're adding, it's a little bit easier than when you're subtracting. The number that we did before, oh, it was adding 2, but one of them was a negative. Where the problem that we're dealing with, they're all positives. So we can leave it in its current form of mixed numbers. So let's try it. 17 1/2 plus 15 7/8 plus 29 3/4 plus 15 3/8. Now, we still do have to get at the common bottom, so I notice I have 2 or 3 different bottoms at this point. So I have a 2, an 8, and a 4, and we really want them to be the same. 2 and 4 both go into 8, so let's use 8 as our common bottom. So we're going to multiply the 8 by 4, because 2 times 4 is 8. If I do it to the bottom, I have to do it to the top, so 1 times 4 is what I'll do. I'm leaving the 7/8. The 3/4 I'm going to multiply by 2, because 4 times 2 is 8, which means I'm going to multiply the 3 by 2, and I'm leaving the last one alone. So let's rewrite these. So I have 17, oops, I messed that one up. Let's get rid of that. Okay. Forgot to write the multiplied part. 1 times 4 is 4. My pen has just quit working. Let's try this one more time. There we go. Okay, so 4 times 1 is 4. 2 times 4 is 8. Okay, on the next one, we're not changing the 15 7/8. Our 29 3/4. We took 4 times 2 and we got 8. 3 times 2 and we got 6. And I'm running out of room, so we'll have to move down. We're leaving the 15 3/8. So I'm actually going to borrow a little bit of the space below here. And I'm going to rewrite these in a different order, which might make more sense. So let's put them actually in a vertical order. So I have 17 4/8, 15 7/8, 29 6/8, and 15 3/8. So let's go ahead and add the whole parts first. So either in your head or with your calculator, take 17 plus 15 plus 29 plus 15. So I got 76. Now remember, 8 is like a name, so it doesn't change, it stays 8. So now we're just going to add the top numbers. So 4 plus 7 plus 6 plus 3. So I have 28. Now we can't leave an improper fraction in a mixed number, so we are going to have to convert this 20 over 8. First thing, let's take it and reduce it. 20 over 8 is divisible by 4. If I divide the top, I have to divide the bottom. So 20 divided by 4 becomes 5. 8 divided by 4 becomes 2. So 28 is equal to 5/2. Now we want to ask ourselves, how many times does 2 go into 5? 2 goes into 5 twice. 2 times 2 is 4. And I have a remainder of 1. This is a whole 2. It gets added to the 76, so it becomes 78. I'll write the answer up here on the top next to it. And then I have 1 left over, so that's the top of my fraction, and the bottom of my fraction is what we reduced to, which was a 2. If during this video you got lost in all of that, let me know and I will send you a new version of that so it's not so cluttered. And we can't forget to answer our units. So it's in inches, so you can either use the inch symbol or you can write out inches. Okay, 22. A planner removed 1/5 of an inch from a 1 5/8 inch board. Find the thickness of the finished board. Because he's removing it, it's actually a subtraction problem. So we're going to start with the larger number, which is 1 5/8, and we're going to subtract 1/5. So let's do like we did earlier. Since we're subtracting, that's always a good time to not use mixed numbers. Let's go ahead and turn it into an improper. So we're going to go 8 times 1, which is 8. 8 plus 5 is 13. So we have 13/8 minus 1/5. I can't subtract these because they don't have common bottoms, so I have to get them common bottoms. So we're going to multiply the one side by the other side. So this is a 5, so I'm going to multiply the top by 5 and the bottom by 5. This bottom is an 8, so I'm going to multiply this top by 8 and this bottom by 8. So I'm going to move down here. 13 times 5 is 65. 8 times 5 is 40. 1 times 8 is 8. 5 times 8 is 40. Now what I am going to do is go back to what we talked about earlier with always adding the problem, but we're going to do a negative here, which is fine to switch. So now I'm back to doing our integers. Our bottom is 40, that's our name. So I have 65, I owe 8. Since I have more than I owe, my top is going to be a positive. 65 minus 8. 65 minus 8 is 57. So now we're going to ask ourselves, does 57 and 40 have anything in common? And they don't, so I can't reduce it. But let's go ahead and change it back to a mixed number like it started as so I can see what was left. So 40 goes into 57 one time. It had 17 left over. So I have 1 17/40 inches left of my board. Okay, so we have added fractions, we have subtracted fractions, and we've done some scenarios with those. So now we have left multiplication and division. The nice thing about switching to multiplication and division is we don't have to have a common bottom or a common name in order to do the problems. You just have to go top times top, bottom times bottom. So everything just moves in a horizontal fashion. So let's look at our tops. We have a positive 4 times a negative 7. A positive times a negative, since they're different, our top is going to be a negative. 4 times 7 is 28. Positive times a positive is a positive. 5 times 9 is 45. Ask yourself if any number goes into 28 and 45 other than 1, which it does not. So that's your answer. When you're dealing with integers, which is a whole number, whether it has a positive or negative sign in front of it, and you're multiplying by a fraction, it's better if you have two fractions. So what you do with all of these numbers is you place them over the number 1. That way you have a top and a bottom that you can multiply with this top and this bottom. So again, we do top times top, bottom times bottom. So I have a negative times a negative. The tops have the same sign, so my top will become a positive. Same signs go to positive. 8 times 10 is 80. Now I'll do my bottom. 9 times 1 is 9. Does anything go into both 80 and 9? And the answer is no. This is an acceptable answer. You can leave it alone if you want. If you want to switch to a mixed number, ask yourself, how many times does 9 go into 80? It would be 8, which is 8 times 9 is 72, leaving you with 8 left over, and the bottom stays a 9. So you're welcome to answer 80 over 9 or 8 8/9. Okay, we're almost there. So let's do the situation, and then we have division. A certain job requires 37 pieces of electrical wire that are each 2 feet 3.5 inches long. What is the total length of wire that is needed? So I have 37 pieces that are this long. I'm not very excited about adding 2 feet 3.5 inches 37 times. So instead, let's multiply it. And honestly, 1/2, you could do it as a 0.5 if you prefer. But we're going to separate this, and we're going to do the feet, and then we're going to do the inches separately. So 37 times 2, that'll take care of the feet. 37 times 2 is 74. So we know we have 74 feet at this point. Now we have to do the inches. So I have to do 37 times 3 1/2. Now, we can't do this in a mixed number. So we have to change this mixed number to an improper. So we're going to keep the 37, and all whole numbers or integers get put over 1, so we have a fraction. We're going to do 2 times 3, which is 6. 6 plus 1 is 7. The denominator stays the 2. The bottom number stays a 2. So now we have a fraction times a fraction. So we're going to do top times top, bottom times bottom. 37 times 7 is 259. 1 times 2 is 2. I don't want to leave it in this form because it's not very helpful. So we're actually going to divide 2 into 259. And I have 129 1/2 inches. Now this is a lot of inches, and so one of the things that these situations do is you have to go back and learn or know some previous information. So what we need to know here is that 1 foot is equal to 12 inches. And I'll write that over here in the corner. 1 foot equals 12 inches. So we actually would like to take as many feet out of this 129.5 inches as possible. So I'm going to take this 129.5 inches and I'm going to divide it by 12. So we're just going to work with the 129. 129 divided by 12 goes in 10 whole times. So let's look. 12 times 10 is 120. So I've used up 120 inches if I do 10 feet. That leaves me with 9.5 inches left over. 129.5 minus the 120 that make the 10 feet, and I'm left with 9.5 inches. So we're going to take these 10 feet and we're going to add them to the 74. So now I'm at 84 feet. And I had 9.5 inches left over, so I have 84 feet, 9.5 inches. That is my total length of wire. It's a lot of wire. Okay, last but not least, division. So here I have fractions and I need to divide them. So just like we changed any subtraction problem to an addition problem, we're going to change any division problem to a multiplication problem. So we keep the fraction in the front the same, stays -5 over 9. We switch the division to a multiplication, and we take the 3/4 and we flip it upside down. So now it is 4 over 3. Once we get to this step, it's the same. We still do top times top, bottom times bottom. -5 times 4. I have a negative times a positive. They're different, so it's negative. 5 times 4 is 20. Positive times a positive, they're the same, so the bottom's positive. 9 times 3 is 27. Does anything go into 20 and 27 besides 1? Definitely not. So that's your final answer. So let's look at this one. We leave the front fraction alone. We're going to change the division to multiplication. We're going to take the second fraction and flip it upside down. I did go ahead and leave the negative with the 10. You can do that, or if you have a different way, that's fine. Top times top, bottom times bottom. Negative 8 times 7, negative 56. 9 times negative 10, negative 90. Now there's a couple things working here. I notice that I have a negative being divided by a negative. Those are the same sign. So two negatives make a positive. So the first thing I can do is this really is the same as 56 over 90. The next thing that I notice is they're both even numbers. So they're both divisible by something else. So let's go ahead and divide them by 2 since they're even. Way I can make them smaller. 56 divided by 2 is 28. 90 divided by 2 is 45. Now you can ask yourself again, does anything go into 28 and 45? And the answer is no. So that is your final answer. Okay, last problem. Here we go. An automobile traveled 427 1/5 miles on 13 3/4 gallons of gas. How many miles did it get per gallon? Most of the time if we're doing this in life, we don't get that specific with the 1/5 of a mile or the 3/4 of a gallon. We usually just do whole numbers. But for the sake of this problem, we're going to go ahead and do the process with these fractions. To find out miles per gallon, if you get in the habit of watching out for this word per, whenever you see the word per, it's trying to tell you that you need to divide. So we'll be dividing these fractions. So we have 427 1/5 that we need to divide by 13 3/4. Just like we can't multiply mixed numbers, we can't divide mixed numbers. So we're going to have some nice big numbers here. First thing we have to do is switch these to improper fractions. So 5 times 427 is 2135 plus the 1, so we get 2136 over the 5 because we don't change the bottom of the fraction. Right now I'm going to go ahead and leave this as a division just because we're switching the fractions to impropers right now. 4 times 13 is 52. 52 plus 3 is 55. And the bottom still stays the 4. Now we don't do division. Remember, we switch it to multiplication. So we're going to leave the first fraction, 2136 divided by 5. We're going to switch the division to multiplication. And we're going to take the 55 over 4 and flip it upside down. Now we can do our multiplication. 2136 times 4 is 8554. Nope, it's 8544. Sorry about that. 5 times 55 is 275. Let's see if 8544 is divisible by 275. Goes in 31 times. These are some crazy answers. They're huge. Now these 31 times have used 8,525 of the top. So to get the remainder, I need to subtract that. 8544 minus the 8525 leaves me with 19. So that's now the top, and my bottom is 275. So I'm getting a little over 31 miles per gallon. I should put miles per gallon, because I should label my answer. If you need any further information or further notes, please contact me by email, and I will be more than happy to send you some other information to make this easier for you. Thank you and have a good day. Bye.